Hello, everyone. My name is Maysam, and I'm a technical educator on Google's engineering education team, where I lead several efforts in machine learning and data science education. I'm also the editor of the new edition of the People Plus AI Research Guidebook, which we'll be talking about today. So in this workshop, I'll be presenting some of the features of our new resources that we've added to the guidebook and we're launching this week. And we'll go through an example workflow where we'll highlight a lot of these resources. So all you'll need is your browser and be ready to follow along. Let's get started. So this week, we're introducing the second edition of the Pear guidebook. We introduced the first edition 2 years ago at I/O as well. And since then, it's been used by over 250,000 people across roles and across the globe. We're now excited to introduce a set of updates to make it even more actionable. So you may ask, what's in the Pear guidebook and what can we expect now? Well, the guidebook can help you build human-centered AI products and can enable you to avoid common mistakes, design excellent experiences, and focus on the people as you build AI-driven applications. It was written for UXers and product managers as a way to help bring a human-centered approach to AI product teams, but it should be really useful to anyone in any role wanting to build AI products in a more human-centered way or to learn about that. So, what's new in the second edition? Well, we're excited to introduce some new updates to make it even more actionable than the first. In the first edition, if you're familiar with it, we released 6 chapters that cover key parts of the AI workflow, such as defining the user needs and success metrics, collecting data and preparing it, mental models, explainability and trust, and feedback and controls, and dealing with errors when they occur in a graceful way. And I'm going to give you a tour right now of the second edition of the Pear Guidebook before we get started. So here's a site. What we've heard from feedback from the first edition is that although you all find it very useful, you'd love to see smaller, more actionable pieces, and you'd love to know how to use these pieces at the right time in your own workflows. So one thing that we've done is we've broken up some of the content into smaller chunks, and a key type of chunk that we have is the design pattern. So when you get started, you can actually get started by searching for specific little chunks of best practices in these design patterns. And to help you find what you need at different parts of the process, we've added this navigation where you can filter the content by guiding questions, which are really some typical questions that people tend to ask while getting started or working through their AI workflow, such as, how do I get started with human-centered AI? When and how should I use AI in my product? How do I onboard users to new features built with AI? How do I explain this AI to users? How do I responsibly prepare a data set to train a model? And how do I help users adjust their trust and decide how much to trust a product in the process? What's the right balance of user control and automation? And how do I support users when something doesn't go as expected? So in this workshop, so we'll be using a lot of these design patterns throughout the workshop to take a look at how we can look at an example product or feature that we'd like to implement with AI. The chapters that came with the first edition are still here, but we've updated some of them. So here are 6 original chapters with significant updates to the data collection and evaluation chapter and the explainability and trust chapter based on the latest research. So in the data collection and evaluation chapter, we have added new content on helping you to plan ahead from the very start to put together a data set that is right for your user and product needs. We've also added more guidance around preparing and documenting your data set, and a lot more support for preparing workflows for the people who are going to be labeling and helping you collect data. For the explainability and trust chapter, we've also added more guidance here around helping users calibrate their trust and setting the right expectations for the system's capabilities and limitations, and helping you find different ways to set that trust, to set the expectations with the users so that they can decide how much to trust the product throughout the product experience, from before they even start using the product to the end of their experience with it. So we'll also look at a lot of these through the design patterns that we use in this workshop. We've also added and collected a set of case studies. So right now, we have 4 case studies that we're highlighting here, where different teams have used the guidance that we are presenting in the Pear guidebook. And as you can see, for each one of them, we've highlighted some of the design patterns that they have showcased in the case study. So the first one is on BenchSci, which is a team that has designed a a user-centered AI-powered biomedical research tool. You can also learn more about the Google Flights team and what they have done to display confidence in results and help users decide when to, purchase tickets for flights. And 2 more on the Read Along team and Google's Jigsaw team as well. And you can expect more case studies to be added on a rolling basis over time. We also have the workshop, which we put together, a set of workshop resources for you, which you and your teams can use and customize as you work through defining user problems, making your system explainable, developing feedback and control mechanisms, figuring out how to mitigate system errors, and managing data responsibly. And in this toolkit, you will find a set of workshop slides that you can use and a facilitator guide as well. And finally, there's the glossary, which we had originally and which has been incremented with several new terms that feature in the new content. So that's our tour, really quick tour. And we'll dive into more of these resources as we go through the workshop. Now, in this workshop, we are going to, I'll move on to the next step. So in this code lab, we're going to take an example problem and walk through a process, a simplified one, of course, because this is the time that we have, but we'll use this process to highlight how you can incorporate some of these best practices into your workflow. So let's start with the user need, because of course, what we all want to do is create these products that users find useful and love to use and come back to because they're helpful to them. And so in the example we're going to take today, imagine the following scenario. I'm going to zoom in here a little bit. So imagine that we are creating, we're working on a movie app. And right now, what we have is a list of new releases that we are showing the user. And we also give them the ability to browse by certain, categories like genre, for example. And they can also search for movies in this search box up here. Now, we're thinking that we'd like to actually add some personalization here and provide the user with some recommendations to help them find movies that they may enjoy faster. So as we get started, we'd like to decide first, is AI really a good option for us? So a couple of things that are a good place to start with, good things to do, starting by reviewing the existing workflow. So how do users currently interact with your app? Well, as we said, there are 3 different ways that they can find movies. They can search for a movie if they already have a movie in mind, or let's say an actor whom they usually tend to watch their movies, or a producer, etc. They can just look at the top new releases, the latest releases in that selection there, or they can go by category. So that's what the current workflow looks like. And then they may click on a movie and decide whether or not they want to watch it. Now, the next thing, now that we've established the current way that folks can interact with the app, we'd like to determine if AI can add unique value. So one thing that we can do is we can go to the chapter on, we can go right here into the patterns, and going from the landing page, we can come here to the all patterns section. We can choose, how do I get started with human-centered AI? And the first pattern that we get tells us, determine if AI adds value. So hopefully this is going to help us make the decision if AI is a good solution for what we're trying to do. So AI is better at some things than some others, right? And we'd like to make sure that it's the right technology for this particular problem. So there are types of problems that AI is better suited for, like recommending different content to different users, predicting future events, like weather events or flight price changes, such as what Google Flights case study highlights, natural language understanding, and image recognition. Of course, there are certain cases where AI isn't really needed, and a maybe more heuristic-based solution may be more helpful in that case. And some examples of situations there could be when maintaining predictability is important, the users need complete transparency, or people maybe really enjoy doing that task and don't want it automated, or they want full control of it. So we also have more specific guidance here in the user needs chapter on when to use AI or not. So we can go there, and find the specific guidance. So right here, and let's find the intersection of user needs and AI strengths. All right, under decide if AI adds unique value, let's go through the checklist thoroughly. So when is AI probably better? In our situation, we want to recommend movies. So recommending different content to different users makes sense. That's a check. Prediction of future events, for example, showing flight prices. Well, we are sort of trying to predict also what the user may like. So that's another one. Personalization improves the user experience. Yes, if you, in this situation, let's say we take simple heuristics. So if I'm, let's say, in a certain city and the app recommends to me a movie that's popular in that location, is that as helpful as maybe, an app that could recommend to me movies that it thinks that I like specifically based on what movies that I tend to like? Natural language understanding, recognition of an entire class of entities, detection of low occurrence events that change over time. Those aren't quite exactly a fit for this situation, but we've already got those first few there. An agent or bot experience, but maybe not so much. The last one, showing dynamic content is more efficient than a predictable interface. And in our case, yes, probably users would like to see new movies shown to them, new recommendations when they turn on the app. So those are examples of, good reasons to use AI here. Let's take a look also, just to make sure, at the list of cases where AI is probably not better. Maintaining predictability is one. Well, if a user really wants the predictable interaction with the app, we still have, as we've seen right here, they can still navigate by the latest releases and browse by genre and search in there. So that is still possible. Providing static or limited information, minimizing costly errors, complete transparency, high speed and low cost, and high value tasks. These may not be quite the fit for this particular application, which is movie recommendation. So we can go back here now. And so we've determined that for these reasons, AI is probably a good solution. And we'd like to understand also, do we think that we are improving this user experience? So we think that we can add value to the app by highlighting to each user the movies that they specifically are likely to enjoy, providing them with a richer user experience than just showing them the latest or overall top-rated movies. And we think that we can also save them time from exploring a potentially really large catalog of movies. So we've decided, all right, let's get started with AI. So our next step following this process could be, all right, now that we've, decided kind of what we want to do, what kind of data do we need to do this? Because AI depends on data. And a lot of times, we may, as we're getting started, we may think, oh, we need to put a lot of this time into picking a model to train to make the recommendations or whatever it is that you're doing. But actually, there's a lot of impact to be had from a lot of benefits to you from getting started really early on planning to pick the best data set that you can for the task that you need to do, because a lot of the work is going to go in there. So let's take a look here. So yes, as we said, how do we get started with human-centered AI? Well, right here, we have invest in early good data practices, which you can also find from by searching for this question in the patterns. So let's take a look at all of these patterns that we're getting now as we prepare to get started preparing our data set. So the sooner you get started planning and collecting your data, the higher quality your end output will be. It's really this planning properly and tying your data needs to your product needs, which are tied to the user needs, will hopefully help you avoid what we have called data cascades. And data cascades can be defined as downstream effects that you can observe in the product, in the user experience, further downstream, that really have root causes in the way of like how the data was collected and how it was prepared. So for example, if you, let's say you're working on an app that can help users detect a type of plant. So they're out taking a walk in nature, for example, and they run across this plant and they want to know if, it may be safe to touch, for example, or if their dog tries to eat it, like, will it be safe for them? And so imagine in that app, the user can take a picture of the plant and would get, a little bit of information, like we think that this plant, may be safe to touch or not. So if, for example, this app, as you're creating an app like this, if you only collect data, for example, for plants that occur frequently in North America, but you later observe that a lot of the folks using this app are actually spread out all around the world, there's a high chance that the app is not going to recognize plants that other people in other locations are going to take pictures of and try to identify. So this is an example of a downstream effect. The data set that you trained your model on does not represent, the entirety of the variety of, data that your users will be trying to work with. So that's an example of a downstream effect, like a data cascade. And so planning really early, defining what you need in your data set, embracing noisy data, which we'll talk a little bit about right now. Planning ahead for data maintenance and documenting your data set, basically understanding what's in the data that you've put together. Where does it come from? What does it mean? Were certain assumptions made when collecting that data and labeling it? Does it work better for certain use cases over others? Are there any, are there any transformations that were applied to the data in preparing it that you should know? Maybe the data was aggregated in a certain way, or certain, maybe there was some missing value and certain ways were dealt. You've dealt with that in certain ways to, replace those missing values with a specific value that has a particular meaning. Maybe the data collection process changed over time. So these are all things that are really important to have documented and part of your data maintenance plan. And of course, throughout this process, partnering with domain experts as much as possible. So if you're working on an app to detect, plant images, to detect plants from images, then working with folks who know a lot about that would be really helpful. And doing so throughout the process, from the very beginning through the entire development life cycle. So that's kind of an umbrella pattern. But as I mentioned, one of the things that we're going to look at right now, and I've highlighted in this workshop, is this pattern on embracing noisy data. So I mentioned in the last step, as you're documenting your data, maybe there were some issues with the data, maybe there was some missing data, and it was, in preparing the data, you've dealt with that in a certain way. But, we sometimes think we need our data set to be really neat and like well formatted and well prepared for, machine learning. The idea here in this design pattern is to say that we really need to embrace what we're calling noisy data, that means messy data. That means data that isn't particularly well formatted at the start, because this sort of data will probably reflect the data that your users will be using in real life. So, for example, in the case of the plant app, you shouldn't really expect that all of the images that users take of plants will really be, super crisp, high quality images. Some of them may be blurry. Some of them may have like a finger, as you see right here, right in the middle, blocking part of the image. It might be shady. It might be like overly bright in there. There may be other objects, blocking the image. So in the case of, the movie recommendations data, we can already start seeing that, if we're going to look at, let's say, movie reviews, well, people submit reviews, there may be typos in there. There may be like emojis and special characters, and those are all things that we want, in there because they represent real data. So that's another design pattern that's relevant here. We've also got another one that I can talk a little bit about now is actively maintaining the data set. So as I mentioned in the first one with data cascades, there are things that can happen, over time. Like, for example, if your data set gathers data from several sources, there may be some changes in data collection that occur for one of the source that you should be aware of. So you need to keep an eye on this potential data drift over time and be aware of them for the impacts that it may have, and making sure that your training data and your live data, understanding the similarities and differences between them, keeping in mind when the data was gathered. Was it a year ago, 5 years ago, last month? How frequently is it gathered? Is there anything that may have changed since then? So these are some examples of patterns that we can see for guidance on preparing our data set. So now let's come back to our movie app. So, we said we want to tie our data needs. We want to start first from putting together some requirements for a data set for this task. So we want to recommend users movies that we think they will enjoy, or we'd like the app to do that. And so we're going to use an exercise from the data collection and evaluation chapter to basically map these user needs to our problem. So who is the user in this case? The user is a movie viewer. And sorry, I'm going to zoom in a little bit. The user is a movie viewer who's using the app. What is their need? Well, they'd probably like to find more movies that they like, easier and faster. How do they interact with the app? What are their actions? They can select and click on a movie, decide to watch it or not, and actually watch the movie or not. Yes. What do we think the AI system output should be in this situation? Well, that would be which movies to suggest. So, as the user, you'd like to see those recommendations and maybe an explanation for why you're seeing that particular recommendation. The AI system, what is the AI system going to be learning? Probably patterns of behavior around accepting movie recommendations, whether the user views the entire movie that was recommended or not. Do they tend to rate reviews for movies? Do they tend to give these movies high ratings or not? These are some examples. So based on all of this, what kind of data sets do we think we need? Well, we probably need movie viewing data from the app to see these patterns of behavior. There's movie information, as we said, like there's the genres of movies and, the year that they came out and who's acting in it, etc. And there's movie ratings and reviews from past users and past viewers of the movie. Then key features that could be needed in these data sets: the viewer movie preferences and viewing history, movie information, and movie star ratings and reviews. Some labels. So yes, the labels, what we're trying to predict in the data set, whether a viewer accepts or rejects, the viewer's acceptance or rejection rate of the app suggestions, their movie completion rate, the ratings and reviews that they tend to give, and possibly the feedback that they give as to why they didn't find a suggestion helpful. So now that we've completed this exercise, we can start to see some potential data sources. So ideally, it's always a good practice to start with, determining first what it is that you need rather than what's available, and then going in that direction if possible. So in this case, we know there's some user data from the app, such as preferences that they may have specified and their past viewing history, movie information from the app, and movie ratings and reviews from other sources to increment that. And here I've highlighted two possible data sets for this application. There are many places where you can look for data sources, such as Google's data set search. When I'm creating educational training, I look on Kaggle data sets as well. And I was going to highlight as well for these particular data sets, you can also find them right here on TensorFlow data sets. So this listing has all data sets, and I can search for IMDb. And this is one of the data sets that you can find in one of the code labs linked from here. And you'll find a description of the movie data set. And here are some examples that you can take a look at. So this is about this particular version of the data set, and you can look at some examples. So here are some actual movie reviews with a negative or positive rating right here. And there's also the other data set. So this is the IMDb one. Another data set on this topic would be the movie lens data set, which provides a lot more information. You can look at this right here. So you can find a lot of movie titles and genres and more information like ratings on them, etc. right here. So once you have an idea of the type of data that you will need, you'll want to consider Google's AI principles and responsible AI practices as examples of frameworks to help work through key considerations such as privacy and fairness, and trying to avoid bias as you prepare your data set. And finally, yes, as we mentioned, make sure to include a lot of realistic data that reflects the variety that is out there in the world. All right, so right here at the end of this section, I've included a couple of additional resources that we won't be going through today just because it'll take a lot of extra time beyond the hour that we have. But there is this recommendations course, which you can take. It's about 4 hours long and will give you a really nice introduction to recommendation systems, what they're used for, how to prepare data for them, how they work. And you can find right here a Colab notebook that will guide you through all of these steps, through loading your data, training a matrix factorization model, getting the embeddings, and training a model to actually, at the very end, get recommendations for movies that are similar to a movie that you may choose. This is one resource. Another resource, and this recommendation systems class, we use the movie lens data set. And then there's this other tutorial for text classification for sentiment analysis. If you want to understand the general sentiment of the reviews in your movie review data set, this lab uses the IMDb data set. You can also open it in Google Colab and run it there. You'll be able to load the IMDb data set, load a BERT model from TensorFlow Hub, train the model and fine-tune BERT, and save your model and use it to determine the generally positive or negative sentiment in movie reviews. So next, all right. So what we've done so far is, we've defined the user need, we've determined that it's like a recommendation systems application, and we've looked at things that we need to know to collect the data. If you've done, when you do those 2 exercises that we just saw in Colab, you'll have a trained model or 2 trained models by then. Is that all? Not quite. So before you put everything together for the product, you'll want to also, of course, design the user experience for your app. And you'll want to, determine how to introduce users to this new AI feature that you've added. And so users don't need to know necessarily in all applications all of the details of how the model works. But there are different types of explanations that you can provide throughout the process to help them better understand the new feature, to understand how it can benefit them, how it can be helpful, and to understand how to use it and when to trust it, and maybe when to be more cautious. So there are many ways that this can be done. As I said earlier, it's building trust with the user is a long process that happens before they even get to the product. So they might hear about it and try to decide whether or not they want to give it a try. So, there are many ways you can do that with like educational or marketing efforts. Once they get started with the product, you may want to onboard them slowly and give them like a play space, or a sandbox-like experience where they can experiment, an easier, simpler way to get started and kind of test out the features. And as they get onboarded, slowly increasing, their interaction with the AI. As they continue to use the product, they give feedback, whether it's implicitly through, taking the movie recommendations, watching the movie, or by providing feedback by saying, this movie, maybe like thumbs up, or this was a great movie, providing a positive review, for example. So we can take a look here also at some of the, I think this was before, some of the design patterns. So let's come back to our design patterns in the guidebook, and let's select, how do I explain my AI system to users? So right here, we have 5 patterns that we've highlighted. And so setting the right expectations, explaining the benefit, not the technology, determining how to show model confidence, if at all, which is one that we will highlight in the example in the workshop, explaining for understanding and not completeness, and going beyond in the moment explanations. So let's take a look at some of these. So setting the right expectations. Ideally, you'd like to be transparent with your users about what your AI-powered product can and cannot do. AI is probabilistic, and it's probably not always going to get things right. So at some point, users are going to run into that situation. And it's really important to help users understand that and to adjust how much they trust particular outputs from your system as they're using it. So the idea here is to be transparent about both the capabilities and the limitations. So for example, I mentioned earlier this example of the plant identification app. So one thing that you can do, if you look at the left-hand side, is to clarify that this app, Plant Pal, can help you identify plants that are native to the United States, and that and determine if they're safe for adults, cats, and dogs. So as opposed to a more general message like the one on the right-hand side, where you're basically saying that you can use it to identify any plant and determine whether it's safe for people and pets. Pets, that's a large group. That's like cats and dogs, and could be fish and anything, right? So being a little bit more specific here and helping the user set their expectations. So that's a good practice. And you can read more about these, of course, in the related chapters and case studies where this is highlighted. So explaining the benefit, not the technology. So what users don't need to necessarily, or may not want to, it may not be very helpful for them as they're using the app in the moment to know what sort of model specifically was trained, and to provide them this recommendation. So there are many ways to provide explanations. And you'll probably need to experiment a little bit with users as you're testing things out. But here's one example here. So for this app that's like a tutor and can help you as you're studying. So in the example on the left, we say that OWL is an educational tool that adapts to your learning style and is available anytime to help you achieve your educational goals, as opposed to saying that it is an innovative AI-based chatbot that leverages a neural conversational model and natural language processing techniques, right? So the first example right here on the left puts it in context for the user. What is the expected benefit? Oh, I have a tutor who's going to recommend content to me. So that's sort of, yes, that's an example right here. And this one, determine how to show model confidence, if at all. We'll look at that a little bit later. And explaining for understanding, not completeness. So here is another example of best practice for explaining recommendations for the system. So sharing the information that the user needs to make a decision and move forward. So sometimes it's really complicated to explain why a particular prediction was given in a very small space in the app, for example, or at the time it may be overwhelming or distracting to the user in their flow. So in such situations like this example right here with the app, the plant identification app, you may wish to say, we've identified this image, this plant as being a sword plant because it looks similar to other images that are labeled as sword plants, rather than saying that the app's classification algorithm found that, used all these 20 factors or so to determine that it's a statistically significant match with this sword plant. So these are some examples of design patterns. And let's come back here. So in the following 3 sections, so now we're on section 5, we have 6 and 7, we're going to look at some different ways to explain your AI and set expectations with the user. In this first step here, we will look at how to explain one recommendation, one particular one. In the next step, we'll look at how to display several recommendations and how to display them. And in the last step, we'll take a look at, what happens, what should we do when something doesn't go as expected, there's an error, and how do we help the user go forward. So right here, we want to explain for understanding, not completeness. So coming back to our movie application app, to our movie recommendation app, how would we like to surface, how would we like to explain to the user why we're recommending a particular movie? Well, having looked at all of these best practices that we just took a look at in the design patterns, this could be an example way that we display it. So let's say you have, we had a search box on top, we had the latest in movies, we had movies organized by genre, and we may have movies that we are recommending. So the user picks one of those recommended movies, Dawn in Dublin, and they get a little information about the movie, and they get this box right here that says, why am I seeing this? Right here. And one way that you could do this is to show popular reviews for this movie that mention things that the user has expressed interest in the past. So for example, if the user has shown that they really admire certain actors' acting and they tend to watch, those movies, like movies that have their acting really called out. So here you may get 3 examples of reviews. Like, this is a review that highlights how wonderful the acting was. And the key words in the review are highlighted, wonderful and acting. The same for the second and third reviews right here, right? So, and there may be more of them. So this is a possible example of displaying an explanation to the user. It's in context, it's personalized, it explains to them why we think, why the app determined that this would be a likely recommendation for them. So as you're trying to, understand also as a developer team, you may also wish to better understand the models that you've trained. And right here, I will just briefly highlight another tool developed by the People Plus AI Research Group, which is the Language Interpretability tool. And if you click on the link right here, you will find a demo for a sentiment classifier. So if you remember in a previous step, I mentioned, there's the recommendation system, and you may wish also to better understand some of the reviews that users have written. So if you click on Explore this demo yourself, you will end up on the Lit tool, where you can sort of explore the model. So this is a sentiment analysis model that was trained on these movie reviews. So there's a lot of things going on right here, but I'll just highlight a few things. So in the left-hand top side, you've got a place where you can visualize some of these reviews in embedding space. You can look at individual items, individual reviews in your space, in your data set, and the sentiment label that was assigned to them. There's a data point editor right here where you can edit a review and submit it. There are results right here, and so performance predictions. And right here, I wanted to call out the explanations tab. So right here, if you pick a movie review, you can, I just had it, right. So you can see the sentence, the individual tokens or words in the sentence highlighted in terms of how much they have contributed to the model's decision-making. So you can explore a lot of the resources. There are many tutorials and demos available right here on the lit pages. So coming back here, so you can use this tool before deploying a model, when testing the model for fairness, to debug individual predictions. As you saw, we were able to look at individual data points in the data set. And when comparing a new model when comparing a new model to an old one, these are some example use cases. So now we've looked in this step at how to provide an explanation for an individual recommendation. In the next step, let's look at how we can surface several recommendations, right? So as we said, the user comes on the landing page, they may get a number of recommendations. And how do we want to express our confidence in the different recommendations? Do we even want to, right? So again, let's go take a look at what the patterns say. And I think we have it right here. So under explaining my AI system to users, we have a design pattern called determine how to show model confidence, if at all. So, in some situations, showing model confidence may not be very useful or not very helpful to the user. So if a user is shown, two suggestions, and one of them has this 85.6% confidence, and the other one is 86% confidence, it may be a little challenging for the user to know, what's the difference, and what's the margin of error? How much should I trust this? How should I move forward, basically? So trying to make this more actionable, there are different types of displays that can be used to surface confidence. And as you can see, if you take a look later at some of the case studies, the Google Flights team has experimented with different ways of showing confidence in results. And that is also the recommendation, trying different approaches with the users, putting them in front of them, seeing what they find helpful, what they find useful, what's confusing early on. But here is an example right here for PlantPal. So on the left-hand side, we're showing confidence in a way that is easier to interpret for the user and make a decision. So the app is saying it is most likely safe, but double check if you have kids, pets, or other concerns, which seems more helpful than the recommendation that's on the right-hand side, which says that it's 82% safe. And there are many ways to show, confidence, as you can find in the explainability and trust chapter. One can show a numeric value. One can show different categories, like best matches, medium matches, or try these, or less good, matches. And so in this situation, let's come back to what we're working on right here. We want to display confidence. So when we're showing a list of movies, we would like to give the user some way to decide which one to take a look at. And in this situation, we may decide to put the n most likely classifications, or recommendations. So right here, I'll zoom in a little bit further. If we have our recommended for you list, we may choose to order them by likelihood, right? By that, the score, the confidence score. So Cosmic Chronicles got a higher confidence score than, let's say, Astral Vision. And so, yes, right. So this is one way of doing it. Now, we've looked at how to provide some explanation for a single prediction, a single recommendation, and how to show several recommendations together and help the user make a decision how to proceed. But what do we do when there's an error that occurs and a recommendation may not really be what the user wants or needs in that situation? So what does the user experience look like in that situation? And you'd really want to ideally give the user a way to move forward. And this, giving them ways to recover after an error really empowers the user while maintaining the usefulness of your product. So there are different types of errors that are highlighted in the chapter on errors and graceful failure in the guidebook. So user errors, where the user performed an action, ended up in an error state. System errors, where, there's like, and I'll give some examples here, or context errors, like these are the main types. So we'll look at some different examples here now that illustrate the different types of errors that can occur in this movie app. Let's think about this a bit. So one example error could be, the app has provided the user with a recommendation for a movie, but the user has actually already seen that movie at the movies. And this recommendation is not technically wrong. I mean, the user went to the movies and watched the movie, so they did select it, but it's also not really helpful to the user. So this is an example of a context error. The app is missing the context that the user already saw it at the movies. Another possible error. The user gets a recommendation for a movie that they've already seen and they didn't like. This one is sort of a mix, right? So there's a bit of context because they've already seen it, but they also didn't really like it, so it wasn't a very good recommendation. Another example, the user gets a recommendation for a movie in a genre that they don't usually enjoy. So the user will think this is probably an error. Why did you recommend this movie to me? It's not really, doesn't work with, other things that I've enjoyed in the past, or that I really enjoy. And finally, an example where the user gets a recommendation for a movie that is no longer hosted on the app. So this one is a clear system error, right? So these are a few examples of types of errors that can occur. Of course, there are other situations, applications, in the movie app, the consequences of getting a wrong recommendation are, not so severe. The user can easily adapt generally, but there are a lot of cases where, you need to be a lot more thoughtful and plan ahead, provide the user with assurances of what will happen and a plan in case the recommendation is not the right one at the time, and giving them a way to regain control in that situation. And there are design patterns for that as well. Right here. So, great. And there are a number of design patterns here. So automating more when risk is low, automating in phases, and giving control back when automation fails. But for now, since we are talking about movies and in the app, what we can do is we can let users give feedback if they get a recommendation, such as one of those where they are not interested in that movie or they've seen it and didn't like it. So let's look at this pattern. So let users give feedback. So, as we said, AI is probabilistic. Things are going to happen. The app is not always going to guess a movie that the user really wants to see every time. So when your AI system behaves in a way that the user doesn't expect or want, it's good to have an option to let the user share feedback. This is also a way to get the user to teach the AI, and it sort of builds in that process where the AI is improving over time as it learns from that particular user, from the user. Ideally, you could use that feedback also to improve. So you'd be improving the model using that feedback. Feedback can be done in many different ways. It can be done using, a thumbs up or thumbs down. The user can decide to hide an unwanted recommendation. A user can flag it if they find it problematic or report it. And there could be other feedback flows like a feedback box, etc. In the case of the movies, the user can also, so if the user watched it, they can give like a lower rating, for example. There are many possible ways. Yes. And what you'd like to do ideally is also, a good practice is once you've, the situation has occurred, you've asked the user for feedback, you'd like to also tell them, if possible, like what action will be taken to deal with the situation, and when that will take effect. So in the example here in the design pattern, the user provided feedback on this run that was recommended to them, which they found too hard. So they clicked on that and they got feedback immediately that the route is being updated for them. Versus, this example on the right-hand side, which just says thanks for sending feedback and doesn't really tell you, when that the change based on your preferences is going to take effect. So this shows users really how actionable, it is, right? So let's come back here to our example where we're in the movie app. And let's see right here, trying to zoom again. All right, so as we've seen in the last few steps, like we now have this recommended for you row, and the user maybe clicks on the first movie and they found that, okay, this is not really for me. So they get an option by clicking right here to say that they are not interested. And then, so that's an example of feedback. And what happens then right away is that movie was removed from the list, and there is a message right on the bottom here that says Cosmic Chronicles was removed from your recommendations. And there is an option to undo it because, of course, the user may have clicked by mistake, or they may, decide to bring it back, or whatever it is. It's possible to undo. And the effect happened right away, and they were notified. It was communicated to the user. So, all right. So we just saw that was an example for working through a possible error and communicating it to the user and giving them a way forward. So that brings us to the end of our workflow. It was just a simple example to highlight some of the resources in the People Plus AI guidebook, the new edition. And in this code lab, we learned how to translate a user need to an AI problem and think through it, look at use cases where this AI may work or may not so much, find that it actually works for this particular example that we're looking at. We thought through the process of defining needs for our data set and some considerations and, collecting it, documenting it, maintaining it, so we did that and all the considerations. And then we looked at different ways to provide explanations to users during their experience interacting with the app, from, onboarding them to a new feature and explaining, a particular recommendation that we've made to them in the movie app, to showing, the different, a variety of recommendations and helping them make decisions as they navigate through the content. And we've also shown an example of how to deal with, we've looked at several different types of errors that can occur within the app. And we've looked at a way to deal with the error in the moment by giving the user feedback to help improve the AI and to improve the product. So that brings us to the end of our workshop today. What's next? You can find all of the resources highlighted in this code lab and many more at the Pear guidebook link that I've just used in this session. You have the links to the recommendation systems and sentiment analysis labs and classes online. All of the Pear tools that you can also find. We talked about the language interpretability tool, but there are many other tools there like facets, which you can use to explore your data. There's the what if tool and many other explorables also available on the Pear site. And of course, TensorFlow's Responsible AI Toolkit, which you can use in your process too. And all of the other models available on TF Hub and TensorFlow.org. So thank you for joining today. I hope you found it useful, and please take a look at all this content and give us feedback. We hope you enjoy it. Thank you.